Welcome to Machine Learning with TensorFlow. Let's dive into the events and histogram portion of TensorBoard. In this video, we'll see what event data is, and what is histogram data, and how they are represented in the TensorBoard toolset by looking at some samples. We'll also look at some of the basic code which is required to set up TensorBoard. After you've told TensorBoard what data it needs to record, we'll talk about it in a while. We'll need to serialize that data into a single processable object. It's done here by the line tf.merge_all_summaries. This merged summaries, including all the event data that we informed the TensorBoard to record. For example, we could tell it to record the loss of the classifier, and it'll serialize the object into the log file. You don't really have to know the underlying format of the TensorBoard log files. Just tell it to store what you want to look at in the graph, and it'll do it for you with no trouble. Just be sure not to put numbers, such as NaN, because it'll crash. It can't record such numbers. Sometimes the loss of the classifier becomes too large, and if you try to record that information, then it'll not work for you. This is very similar to injecting logs through aspect-oriented programming. We'll talk about what data we need to grab for TensorBoard before merging it shortly. Now we'll have to create a writer object that will take the process summary from the merged object and serially write it to the pointed log location. Just like the other processable nodes, this merged object is also processable. You just put it inside the session run in the format of an array item, and it'll give you a summary output. Then you'll pass that summary into this writer object, and you'll also pass which step you're currently at. We'll look at it in the next slide. To process this merged object, we'll need a similar approach to the session training of our classifier. You simply pass this merged variable, and it'll give you the summary of all stored variables in the merged object. Now that we have the result summary variable, we just have to pass it to the writer object, and it'll write the summary of the variables for a particular step to the pointed log location. For telling TensorBoard what needs to be stored before merging, look at the code line at the very end. Here we store a scalar summary of the loss variable under the name NN_loss. We add code lines, like these, to different places in our not-MNIST classifier to store different types of data. Again, try to make sure that your loss is not too big for it to record. Otherwise, your software will crash as it tries to record it. We could do all sorts of stuff here to record accuracy and learning rates if our learning rate is accompanied by learning rate decay. Then, we would be able to look at different details and state of our classifier at each step. Let's talk about how to work with histograms and events. Events are scalar graphs of variables, and histograms store the distribution of matrix variables. Tensors. For each time step, with the more frequently occurring variables represented in a darker color and less frequently in a lighter color. Histograms are good to use for visualizing the learnable parameters of our networks, such as weights and biases, that we earlier looked into while training our classifier. Scalar summaries are good for visualizing accuracies, loss, learning rates, epochs traced, and error rates, etc. This is a good example in which we are showing the graph of the cross-entropy, the loss, variable. It's showing that the loss was high at the start of training, and as we train our classifier, we are reducing the loss. Similar graphs could be shown for other values like accuracies and learning rates. The different colors represent the different runs of the same event of the classifier, shown in different colors. In this way, we can easily tell the changes in the graphs from the previous run, and can decide if our classifier is improving or not with each run. For exploring the tensor changes, use histograms. You could see the spreading of the values present in the tensor as our classifier is training. It was less distributed at the start, but more distributed at the end. This is good, as it shows that our classifier is actually adjusting its parameters and learning from our data. To store a histogram, we use tf.histogram_summary. It works similar to the scalar event summary, and you could save multiple runs here as well for comparison. In this video, we learned about the different approaches to save TensorFlow variable data in the form of scalar events and tensor histograms. We learned about how to add code to store, merge and write data to TensorBoard logs, and how to view them, and how to make decisions based on our observations. That's all for this video. Next, we'll talk about how to get the graph of our classifier model using the TensorBoard Graph Explorer, and also what each of the nodes represent in the graph. Take care.